Hi George, just a quick recap video on simultaneous equations, just to go over this method very quickly. You're pretty good at doing it now, I know you've got no problem with it at all, so I just thought I'd do a quick run through and then you asked me about what about this. Of course, you asked me an A-level question, pretty much as per usual. So I'm sure you could do this now yourself. If you want to pause the video and just do it yourself, and then I'll talk through it. So pause the video now. Okay, so hopefully you've done that okay. So what we'd do here because it's a negative there and a plus there, what the best thing to do would be to multiply the bottom by 4. So I'm just going to do that on the go. So 4 times 3 is 12, 4y and 4t. Okay, and now I'll add them together because they're going to cancel out when I do that. So I'm going to get 14x plus nothing equals 42. So x is 3. Once I've got x is 3, I can then put that back into either one of those questions and equations and get what y is. So if I do it at the top, it doesn't particularly matter which one I do, but do it at the top and we get 6 plus 4y is 2. So logically 4y must be equal to minus 4, because 6 take away 4 is 2, so y must be equal to minus 1. Does that make sense? The other one was 12x minus 4y is 40, so 12 3s are 36, minus 4 times minus 1 is plus 4, which makes 40. So yeah, that makes sense. So that's how we can also check it, because we want to also check it's correct. We don't just want to go, yeah, I think that's right. We want to make sure it is correct. So one way of checking it is just put it back into the other equation and make sure that it matches up. So that's what I did there. Or if I did 3x minus y equals 10, it would have worked the same. Because 3 3 is 9, minus 1 is 10. Okay, so we could do that. The second thing you can do is stick it in your calculator. So you press equation, press mode first, then equation, then the top one, number 1. Then you'll get what's called a matrix of values. It'll just be 0, 0, 0, I think. But you just stick in the values. So I put 2, 4, 2, 3 minus 1 and 10. Or 2, 4, 2, 12 minus 4 and 40, it's all the same. And it equals. And when you do that, it should give you x is 3, y is minus 1. So that's another way of checking it. If you've got a calculator to hand, you might as well check it that way. Okay, so that was just a very quick one through of what we did. Because it's important they check it as well. That way, I don't want you to just do the question, check it as well, make sure you get it right. It's a question you can't get wrong if you're able to check it there and then. Don't want to find out later on that it's wrong. Okay, then he said, okay, well, what about this? X squared minus plus 3x plus 2. From equation of a straight line, because we talked about how to find the gradient from the equation of a straight line. What about this situation? So if we look at this one here, I asked you what the gradient of this one would be, and you said 2, of course. But it wouldn't be, because we need to make y the subject. So we need to make it 2 minus 2x, and then divide by 4. Which gives us a half minus a half x. So the gradient actually would be minus a half. And the intercept will be a half. Okay, so we need to have it in that y equals mx plus c format. Even if it's c minus mx, it needs to still be in that format. You can't just take it from, oh, that's the number times by x. Yes, it is, but it needs to be y equals mx plus c. So then you said, okay, well, what about this situation? X squared plus 3x plus 2. Which number in that tells me what the gradient is. Is it this one? And the answer is partly. This one is not going to do anything. I think you sort of tried to argue that it's going to make a difference. It's not, I'm afraid. It won't make a difference. If I've drawn a graph of this one for you to look at. So here it is. Let's try. I can't move it down, but you should be able to see most of it there. And you can see it's not straight. Yeah, it's a curve. It's a quadratic parabola. And it has an infinite number of gradients, this one. So at any point, the gradient is different. So there, the gradient is a tangent to the curve, and it's just a line that looks like that. Here at the bottom, it's actually a horizontal line. The gradient is 0. Up here, the gradient is positive. It's again a straight line. At that point, it would just be a tangent touching it. So I'll tell you what. Let me just think about what that would be. So what would be the gradient of that line? So x equals 1. That's y equals 6. So it would be 5x. Let's try 5x plus 1, that might be close. Yeah, that is close. Yeah, so that would be the gradient at the point x equals 1. You can see that it's that straight line there touches it just at that one point. It's hard to see because it's not very well, it covers it quite a lot, but it's only got to touch it at that one point there, and it has a gradient of 5 at that point. Okay, and I figured that out doing something which is beyond GCSE maths. It's called differentiation. We talked about it before because you asked me about it on the calculator. You spotted a pattern when you were pressing the buttons. A year, maybe 2 ago? Yeah, 2 years ago I think it was. Yeah. So the gradient for a curve is an infinite number because essentially a curve is an infinite number of straight lines which are linked together and made bendy. So the straight lines are very small. If you zoomed in enough, you'd see that it's just a straight line next to another straight line at a different angle. So the part that tells us that it's what the gradient is the first two parts, the x squared plus the 3x. Okay. So what I do is I won't go into details now, but I do something to it, and it changes into 2x plus 3, and that'll tell me the gradient at various points of the curve. So for example, when x is 1, which we looked at, the gradient is going to be 2 times 1 plus 3, which is 5. And that's why I created a straight line, which had a gradient of 5 on it. So I had to go at 5x plus 1, and that turned out to be correct. That's tangent to it. It might not be exactly right, that might be a bit of a guesswork from me, but it's there's a way of doing it, but I won't go into all that now. So yeah, so there you go. So there's your answer. So it's actually an A-level concept you asked me about. We do something called differentiation, discovered by a man from Lincolnshire, Isaac Newton. You may have heard of him. And it was one of the greatest discoveries in the history of maths, and is still used today, very much so. And once you understand it, you probably never, as a mathematician, you'll never go without using it again. I still use it in the stuff I'm doing. Okay, so I'll see you next week. And I hope that made a lot of sense to you.